Hi there, I'm Lockie and I'm a Microsoft Technical Trainer. Wonderful to have you here. In this video series, we are going to be looking at load balancing options in Azure that are designed to handle HTTP and HTTPS traffic. There are a couple of options that are up our sleeve within the Azure ecosystem. So we're first going to look at a little bit of a decision tree of how we get to the right one, and then we'll take a look at them individually. First at Application Gateway, and then at Azure Front Door. Between the two of them, we should be able to find a solution for pretty much everything you need to do in Azure when it comes to that web-based traffic. We are going to be looking at how you pick the right load balancing solution when we're talking about HTTPS web traffic style load balancing. Now there are four major options for load balancing solutions in Azure. The two on the left are the ones we are going to be focusing on because they run at layer 7 of the OSI stack. Application Gateway is designed for regional-based load balancing, things that are running within a single region, whereas Azure Front Door is designed for multi-region load balancing, taking in that web traffic, analyzing it, and ensuring that it gets to the right place at the right time, no matter where you are. Now, picking the right load balancer of these two may not be as simple as I have a regional or a global service that I wish to optimize. So the first thing that I tend to do with customers out in the field is provide a copy of the load balancing decision tree. There's a great interactive version of this in the Azure portal, or you can head to the Azure Architecture Center to view the one that I'm going to show you now. The first no-go point is your application a web app? Because if the answer is that it's a web app, you head down to the bottom and there is a lot of decisions you will need to make. There are some specific things around SSL offloading, security, and if you are internet facing, that will make your decision easy. So follow the decision tree down and you will find all of the solutions have some combination of front door, app gateway, potentially some other load balancers in some way, shape or form. Between the different load balancers that are available, you will be able to find the right solution for you within the Azure ecosystem. So follow the decision tree, make your choice, and you'll be able to find something that works well. In this one, we are going to look at Azure Application Gateway. I want to make sure that you know how to design for it, making the right calls about if it's the right thing for what your application needs. We're going to look at a few different things around the decisions that you need to make to find the right SKU, to find the right routing option, because there are some things you'll need to kind of make as calls along the way there. Let's jump across to a whiteboard, and I want to give you a little bit of an idea about the two major routing rules that are available in App Gateway. So in front of us, we have two users making a different request. Now the one on the left is after a video. We're after cat.avi here. Application Gateway is able to understand the context of what someone is requesting. So we can see contoso.com/video. And what /video means is this user on the left must get redirected across to the video server pool. But we can also see on the right-hand side, someone is requesting an image of a dog. Easy done. Application Gateway, because it can understand this, is able to perform path-based routing. Now, path-based routing like this means nice and easy. One endpoint, the Application Gateway, either a public IP or a private IP, can redirect different users to different pools of servers in the backend. Because we are dealing with layer 7 requests, there is a lot more context we get. Headers, bodies, URLs that allow us to direct users to the right location. Now, by contrast, the other type of request that we can handle in an Application Gateway is not routing by path, but routing by site. This same scenario, but now my users are requesting two different websites, fabricam.com and contoso.com. Application Gateway takes this in its stride. Based on what site the user is requesting, we can direct them across to the correct server pool and get them to the right endpoint. Fabricam, easy, that goes to Fabricam. Contoso, that goes to Contoso. Using these different ruling pathways, we can direct users in the right way to the right part of a site. And you only need a single ingress point, that one public IP or private IP, to be able to handle that traffic. Between the two different rule types here, you'll be able to find a redirection that works for your application. Now, as with everything in Azure, multiple t-shirt sizes, multiple SKUs to pick from. The answer for me is pretty straightforward. Application Gateway version 1 has very specific scaling requirements. You pick a small, medium, or large with the different size of page requests that you have, and it'll be able to handle different types of traffic within it. My preference is to go an Application Gateway Standard v2. This allows for both fixed size, so you have predictable costs and can really control exactly how your application gateway will function, but it also supports scalability, so we can handle more traffic if needed. This gives you that ability to grow into the future. And as application version 2 kind of states, version 2, it is newer, it has some more features associated with it. So if you are trying to decide between the two, look to that v2 SKU. That'll offer the best options for you there. Now, to close things out, I want to get a little bit of terminology correct along the way. Here we have the actual end-to-end of how an application gateway functions, what it's actually doing at each step of the process. First things first, a user request comes in to an application gateway, and the thing that actually dissects what that user is doing is a listener. The listeners are taking in that information about the URL the user's requesting, the body, the header, all of that info, and it is giving us a stack of information to then process with our rules. So listeners pass information to our rules to direct to different endpoints. And please note, virtual machines absolutely supported. Individual application services like we're seeing in the Azure ecosystem, absolutely. On-premises servers, not a problem. App Gateway can redirect users wherever you need them to go. If you're doing a partial migration like some of my clients did, and you want to move most of the stuff to the cloud, but there's that one pesky HR system that just can't move off physical kit, you can get the partial migration to work real easy with an application gateway like this. Redirect the users on a path-based system and just say if they're trying to get the HR system, send them back that way. There's some really cool flexibility you can get in your architectures, especially when we're looking at migrations or looking at hybrid style workloads that really do shine with the application gateway. Now, the other one to note now is also the web application firewall. This is an optional feature that you can enable on your application gateway to begin analyzing the data that's coming through for the listeners for different types of threats. Maybe looking at common threat actors around SQL injection or HTTP different attacks that can happen at that level. No matter what you're doing, there is a really cool option available in this framework that will help improve the security of your application and make your life as a network administrator easier. Up ahead, we're going to be looking at Azure Application Gateway, and I want to show you some of the configuration steps that you can get along the way. And there's a lot of potential configuration that you can put in. Every one of the things that you are seeing here, health probes, listeners of different types, different URL-based routing requests, you can kind of configure this to your heart's content. Depending on how your application is laid out, and depending on what pieces of the puzzle you need, you can put Application Gateway together in a whole range of different manners. So we're going to look at some of the constituent components first, and then I'm just going to take you through one by one some of the different features that I feel are really worth highlighting. First things first, this is the structure of an application gateway, and I've chosen this layout because it shows the data direction, how things are actually talking to one another in a practical sense. For starters, we have the front-end IP. This can either be a virtual IP that exists in your private network, or it can be something that is existing from a public IP perspective. Your call depends on your application architecture, but I do tend to see this one with a private IP used internally a little bit less commonly. Doesn't mean it's not up for grabs though. Use it if it works. Next, we have the listener. The listener is the magic sauce. It's the thing that actually goes through and pulls apart that request the user's making, grabs all the details about the header, the body, all of the things that the user is requesting, and then it's able to pass those details back into the rules, which are the things that actually tell us where we're going to direct that user. Do note that there are two things on the side here, little features that I haven't talked to. These port and certificate combinations are to do with SSL offload. If SSL offloading is something that you are looking to achieve, Azure Application Gateway is the best place to do this in Azure. When the data is received, we're able to decrypt the data and pass it along in an unencrypted format for further analysis. And then on the way out, we can re-encrypt the data so when it goes back to the user, they are confident in the security of the information that's being passed through. This is an optional feature, but it is a really nice one to know about when you need to turn it on. All right, working our way down from the rules, we get into some of the different configurations for the backend. There are two major different options that are here. Either backend pools pointing at virtual machines and app services that exist within Azure, or we can look at just HTTP settings directly, redirecting users to arbitrary fully qualified domain names or IP addresses. Both of these require different types of probes to understand what their healthiness looks like. And in Application Gateway, you can configure extremely detailed health probes. That's actually what I want to talk about next. So let's move straight to it. Health probes in Application Gateway are really, really detailed. And I mean that in the sense that you have a configurability level that is extremely high. What is the exact HTTP error code or return code that reflects a healthy system? What is the specific page you need to listen to make sure that that site is up and running and successful? Is it that the site is running, or is it the site and the backend server is going, or is it that some other process has finished running? Whatever it is, if you can design a return for it, we can match it and get that request done through. So this is an extremely, extremely useful thing to have on hand because the level of detail in your hands is very high. Now, health probes are one part of the picture. The other thing we need to look at is the listeners, because remember that comes in at the front. So health probes are at the back saying if something is ready. Listeners are at the front saying where we need to redirect people. So listeners come in on a specific front-end port, and then we apply rules to be able to redirect users as required. The listener will pick up the details and pass through information as we go. But there's a really cool little thing that I want to point out down here. As well as the associated rule, take a look at this bottom section. Custom error pages. If your application does not have inbuilt custom error pages or error handling for specific HTTP error codes, you don't need to worry about it. You can actually insert static pages to be returned as error code return pages right here. I had so many customers that used Application Gateway just for this feature when they were looking to migrate legacy web applications and didn't want to have to go through a full redevelopment process. The simple fact that they could return error codes and make it a friendlier experience for their users was just fantastic. So even something simple like this can make a huge difference and a huge impact to the way that things look to users that use your site. Now, another thing that can make a big difference is redirections. Now, there's a lot of reasons that we would need to redirect someone away from the site that they've requested. Maybe it's a permanent redirection because something's located elsewhere, or it's a temporary one. Based on either global requests, i.e. every time someone comes into a specific location, always route them, or maybe even if they go to a specific path of a site. The cart example is a great one here. So someone attempts to get their shopping cart, redirect them across to the shopping provider that hosts that. We are able to return these codes in a custom format for each different type of rule. There is Huge potential here. Again, allowing you to modify and make changes to sites and applications you may not have full control over in an easy way. Super, super useful, super nice if you need it. Okay, last thing, the rule types. When we are looking to route different users, there are either basic rules, these are the ones where all requests come through and we forward those along, or various types of path-based rules. These can be either a path-based or a full site-based. Each of the different listeners can handle these in different ways, so make sure you're configuring these correctly. Most users I worked with tended to set up path-based routing just because it was useful for certain scenarios, but for the majority they used it in the same way a basic rule would. You can mix and match as best you need to fit the scenario you're looking for. Now, the last useful feature I want to talk to is the rewrite policy. If you are using something like PHP in the backend, and you need to insert certain details to make the web server in the back process in the way that you need it, well, a rewrite's often the easiest option available. Something that allows you to take a URL and add some extra information, or when a user comes in with one request, modify their request on the way into the back, and then make sure the user doesn't see that information as it gets passed back through. There's a really versatile rewrite policy system within Application Gateway allowing you to modify these requests on the fly. You associate them directly to rules, and you can easily add this extra conditional component to it as well. So configure it however you need, but again, know that it's there. And I think that's the big lesson that I want for this. Application Gateway has a huge number of optional features. You can turn none of them on and still have an incredibly functional load balancer that will keep your site up and running at all times. But if there's other things you need, it's there, and it's the toolkit that you need to get your site running in a performative manner. Up ahead, we're going to be looking at Azure Front Door, but specifically just the designing elements. I want to let you know some of the key features, where we look to use it, and a little bit of history about where it came from. Azure Front Door is actually a combination of a number of services, all kind of put together. And since it has things like SSL termination and end-to-end to SSL encryption capabilities, it's good to know what you get in the different feature sets. So we'll start with a little bit of what it is, and then a little bit of where it came from, just to make sure you've got all your bases covered. So let us begin with a simple architecture. I know it's not that simple, but it is a good representation of a nice, relatively basic setup using Front Door. First of all, we have a user requesting contoso.com. But what are they requesting? That matters a lot, because Azure Front Door runs at the Microsoft Edge. When a user hits the secure edge of wherever they are, the closest onboarding network point, we will analyze the details of what they are requesting and where they wish to go, and we can redirect them accordingly. Now, I have 3 different areas that I want to redirect this customer to, depending on what their request is. And there's a lot of little nested bits and pieces in here. First of all, we have just a general slash. Okay, so we haven't requested something specific, so this is kind of a catch-all. If it's a catch-all, we can send them anywhere. We've effectively given a load balancing option across 3 separate regions with the ability to distribute traffic with ease. But what if they are requesting the search feature? Well, if we're going to search, that is hosted in a specific Azure region on a web app. Redirect them there. So we're able to do different path-based redirections very easily. But the last one, that's the one that I find most impressive. We can take a request from a customer entering the Microsoft Edge network, and if they match a request for, in this case, statics, we can direct them anywhere. In this particular case, we've directed them to an external cloud service. This is the power of Front Door. Rather than waiting until a user gets directed to your region where you're hosting your web app to find out that they're in the wrong spot, we are able to do layer 7 redirection at the earliest possible point, the moment that they enter the Microsoft Secure Network. Azure Front Door in its current state is a combination of 3 products. Azure CDN, a content delivery network designed to optimize the delivery of static images by caching them at the edge and allowing us to deliver those in a lower latency to users directly. The old Azure Front Door, we've detailed what that one does. That's about redirection of traffic to different users based on the request that is coming through. And the third is the Azure WAF, the Web Application Firewall. This allows us to analyze requests that are coming through for threats and be able to redirect or block traffic that matches a threat profile. Azure Front Door in its current form is effectively all 3 of these tied together. Now there are 2 different SKUs available, the 2 different t-shirt sizes, depending on what you need for your particular application. For many clients, the standard SKU is all that's needed. We have the ability to do content delivery optimization in the form of that CDN. You still get the global load balancing and SSL offloading capabilities. It's most of what you need there. The big thing that we get with Front Door is the integration with WAF, the ability to have threat intelligence integrated through, and many more security features. So depending on where your security posture is and where it is you're looking to do the analysis of user requests, we can either go the standard or we can go the premium SKU. And it's your call which way you want to go. Make sure you pick the right one for your business and for your particular application that you're looking to protect. Azure Front Door has a lot of really interesting options for a network administrator looking for the best way to balance an application at a global scale. Because of this, there's some pretty hefty configuration that you can choose to put in place. So I want to make sure that you know a lot of the key features and how to get them in the right order. We're going to jump through how a front door is created in the portal. We're going to look at some of the different ways that we can create different back-end components. In Front Door, those are known as origins, as well as a little bit about health probing, because it does work in quite a unique way compared to other load balancing options out in the market. So let us begin with the simplest spot. Where do I create a front door? Head on over to the Azure portal. Feel free to use CLI or PowerShell if you prefer. And then you can just create the front door directly from there. I'll be demonstrating this at the end to give you a bit of an idea about how this goes through. The next thing you'll need to pick is a globally unique endpoint name, somewhere we can direct customers to access the site you're looking to protect and put behind the load balancing, as well as the origin, the place that we need to direct them to. Now, before we go any further, I think it's good to do a quick little idea of how routing actually functions within Front Door. Because if you don't know how it routes, you might not know exactly how you want to configure it. Have a squiz at this. This is the step-by-step of how traffic is handled when it actually reaches the front-end point of a front door instance. The first thing that occurs when a user sends a request to the Azure Front Door is we find out what they're requesting. I know it seems simple, but based on what edge location they're coming into, we can tell a lot of things about where they are. We can also get information about the sort of thing that they are requesting, what particular site, what URL, maybe subpath data as well. Once we have that, we establish a TLS connection directly from the user straight to the front door itself. So this is where we are establishing that secure connection to send data. Once this is done, we analyze to see if there is any threats if you have WAF enabled, match the route based on the different groupings and rules that are in place, then do a quick check to see if any CDN content applies. So if there is a static image, a static page, or maybe even a database entry that is cached that we can return, we will return that to them. Once it has gone through all of that, the last thing we actually do is check to see if there's anything left. Do we still have to direct the user somewhere? And if that's the case, we find the right origin to send them to, the right spot in the back end, and we redirect the user there. So there is a huge amount of data processing and data analysis that happens at that edge location. We are doing both left side matching, trying to get an idea of the protocol that's being used or the site or the path that someone's reaching, as well as right hand matching where we're doing this database request. So the two of them together make up how we route traffic within Front Door. What this all leads us to is that pretty much the first thing you need to do is create some origins, places that we can send traffic to, which we can then define rule sets about what actually goes there. So to create an origin is pretty straightforward. Tell us what we would like to reach out to. So in this case, we're looking at an app service and we've told Azure exactly where that's located. We say what the HTTP and HTTPS config looks like, important because we might want to redirect people from one to the other. And then we can add priority, weighting, little things like that to improve the experience for the user itself. Once all of that's in place, do you want to enable it? Like many things in the Azure networking stack, we can actually configure it and not put it in an enabled state, simply so you can have stuff ready when it's actually ready to go. All right, we've got our origin. How do we know the origin is up and running? A health probe. Health probes in Front Door are pretty unique in that we're not actually doing a full request, a GET style request, to find out the details of if that thing is running. All we want is the header. Just a simple head request that is going to return yay or nay, the site is alive. This is important to know. Much of Front Door and the way that it's designed, the way that we do things with it is to be lightweight. Anything involving a web request can get heavy fast. So we want to make sure that we are limiting the amount of data being sent back and forth in any probes. Even the interval, so the time in seconds that we're sending this back and forth, is much more extended than you might see with other load balancing options because we're trying to keep it lightweight and we're trying to keep it as quick as possible. Now, for those that were paying attention, SSL, anytime we mention secure sockets in that way, we're going to need some sort of certificate-based encryption as part of that. Well, Front Door has you handled. This is one of the best simple features that Front Door offers. When a user comes in and they request an HTTP unsecure site, redirect them across to the HTTPS secure site. That's it. A nice simple routing rule like this can absolutely save you bacon if your application isn't designed to handle that redirection automatically. We can design the origin group automatically to be able to do that redirection just through the nature of Front Door. So everything you need is in the encryption path and the encryption protocol setup of the setup of that route. All right, we've looped around a few times. I think at this point, we're going to jump across to the portal and actually show you how we create the Front Door itself. So we are in the Front Door and CDN profiles page. Yes, they are grouped together because, well, they tend to get integrated with one another, don't they? Hit create here and we can begin the process of creating our Azure Front Door. Note explore other offerings here. Azure Front Door really is our main place for any sort of caching of content in the form of a CDN, load balancing, anything along those lines. But we do still have some of the classic offerings available. We're going to focus on the latest offering in terms of Azure Front Door, and we're actually going to go very straightforward with a quick create here. There are some key settings that will automatically be selected for you that match baseline security profiles and match what most customers are looking for out of their load balancing solution at a global level. When we'll hit continue to create, it will automatically populate many of the things into the profile. Now, a profile is what is going to get deployed at our edge sites. So the first thing that we require, a resource group to deploy to. We'll go with our core networking one here. Resource group location, this is just for metadata, so it is grayed out and will be automatically selected for you. As this is a global service, it's deployed everywhere all at once. And then a name. I'm going to go with something simple like Azure Front Door LMD, 001 Contoso. Beautiful. Next, we need to know the endpoint that it's going to come in and what the origin is that we're looking to target. So in our origin type, there is a lot of types here. There's storage that we can redirect to, great for static content. There's various cloud services and specific Azure services within it. Effectively, just select what you need. But if you don't find the one you're looking for, hit that custom button and you can put in some more details about it there. Once you've got the baseline components in, think about if you're using caching, pop in any details around the web application firewall if you're looking to use the WAF there, and hit create, and you'll be in a good place to go. Front Door is designed to be straightforward to use and very easy to add on to and customize over time. So think about how you can use it in your environment as a mechanism for improving security posture, improving optimization, and generally making your global applications work better.